Welcome to the Year 10 Unit 2 Bonding End of Unit Test for higher tier single subject and trilogy students. Here we go. Right. The diagram represents a magnesium atom. Let's have a look at it. Right, okay, there's the protons and neutrons in the middle. Here are the electron shells. We've got 1, 2, 3 shells. We can tell it's the magnesium, possibly because it's got 2 electrons in the outer shell, but we'll count those protons in a minute. Use words from the box to answer these questions. The words are electron, neutron, nucleus and proton. What is the name of the central part of the atom? This bit here, the central part of the atom with the black and the white bits with the positive sign in it, is called the nucleus. What is the name of the particle with no charge? If I've got no charge, I am neutral, so I'm a neutral neutron. What is the name of the particle with a negative charge? The particle with a negative charge is the particle that orbits the nucleus, and it is the electron. Use the diagram above to help you answer these questions. Draw a ring around the atomic proton number of this magnesium atom. Well, the atomic number is the number of protons. I need to count the protons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Or I could just look on the periodic table where I'd find the atomic number of magnesium 2b12. Draw a ring around the mass number of this magnesium atom. Now the mass number is the number of protons and neutrons in the nucleus. So what have we got here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. 24 protons and neutrons altogether, so the mass number is 24. Figure 1 shows the outer electrons in an atom of the group 1 element potassium and in an atom of the group 6 element sulfur. There we are. So look, potassium, sulfur, outer shell electrons only. We know potassium's in group 1, firstly because they say it's in group 1, and secondly because it's only got 1 electron there in the outer shell. We know that sulfur is in group 6, firstly because they say it's in group 6, but also because it's got 1, 2, 3, 4, 5, 6 electrons in the outer shell. Potassium forms an ionic compound with sulfur. Describe what happens when 2 atoms of potassium react with 1 atom of sulfur. Give your answer in terms of electron transfer. Give the formulae of the ions involved. Right, well, there are enough clues there, but first thing we've got to do is decide what kind of bonding we've got. And the kind of bonding that we've got, well, the bonding is taking place between potassium. Potassium is a metal because it's on the left-hand side of the periodic table. And sulfur is a non-metal because it's on the right-hand side of the periodic table behind the magic staircase. So an ionic bond forms between a metal and a non-metal, and that's what we've got in this instance. We've got a metal and non-metal, so it must be an ionic bond. Before we answer the question, let's have a reminder of what happens in ionic bonding. Right? Okay, a metal. Well, all atoms want to gain a full shell, and the easiest way for a metal to gain a full shell is to lose this outer shell electron, because underneath we've got a full shell of 8. Now we don't bother drawing it because we only ever bother drawing the bonding electrons, or the electrons that take place in bonding for bonding diagrams, but underneath that outer shell I've got a full shell of 8. So if I lost this electron, bosh, I'm there with a full shell. So the metal wants to lose electrons to gain a full shell. It's going to want to lose that outer shell electrons there. Meanwhile, the easiest way for a non-metal to get a full shell is to add electrons. In its outer shell it's currently got 1, 2, 3, 4, 5, 6, and we know for all shells past the first shell, a full shell is 8. So how many electrons does it need to gain? Right, it needs to gain 2. It needs to gain 1 there and 1 there. Then it will have 8 altogether. So, in ionic bonding, what happens is this. The metal gives electrons, it gives its outer shell electron, and the non-metal receives electrons, if you can spell receives correctly. So here we are. Here's a diagram then. Here's a diagram. It's not the example in the question, but it's another example. I've got some sodium and I've got some fluorine. I've drawn all the electrons for sodium, just so it's not confusing the first time around. But after this time, we're only going to draw the electrons in the outer shell. Talking of which, here's the outer shell. Only one electron in it because sodium's in group 1. Meanwhile, over at fluorine, I've drawn all the shells. Just this one time only. The first shell's got 2 and the second shell has got 1, 2, 3, 4, 5, 6, 7 because it's in group 7. So what's going to happen here? Well, for sodium to get a full shell, the easiest thing for it to do is to get rid of this electron here. And what it's going to do is it's going to get rid of it and it's going to give it to fluorine. Right? Like that. Now all of a sudden this shell disappears and underneath I've got a lovely brand spanking new full shell with 8 electrons. Now you're going to say to me, why are these electrons crosses and these electrons circles when they're all electrons and electrons all exactly the same? Well, if I draw a cross to represent electrons for sodium and a circle to represent electrons for fluorine, I can tell whose electrons belong to whom. So the circles are electrons that have always belonged to fluorine. And the crosses are electrons that have always belonged to sodium. So when sodium gets rid of this outer shell electron and gives it to fluorine, there it is. That cross there shows that that's an electron that used to belong to sodium. Right. Now, the thing is, if I lose an electron, okay, I've now got one more proton in the nucleus, in the nucleus somewhere. I've got one more proton than electron. We remember that all atoms are neutral because they've got the same number of positive protons and negative electrons. So if I lose a negative electron, if I lose this electron by giving it to fluorine, I've now got more protons than electrons. And because I've lost one electron, I've lost one lot of negativity, I must overall be 1 plus. I've got one more proton than electrons. And the way I write that, in this instance when I'm drawing all the shells, is to draw the atom with its last 2 remaining shells, put square brackets around it, and then put the charge, which is 1 plus. Meanwhile, fluorine has got this extra electron from sodium. Doesn't belong to it, so it's got one more electron than protons in the nucleus. So it's got more negative electrons than positive protons, and it's got one more electron than positive protons, so its overall charge is going to be 1 minus. So I draw the electron structure. In this case I'm drawing all the shells, but I'm not going to soon. Put square brackets around it and then put 1 minus. There's an easier way of writing this, of course. I can write Na plus, that's the way of writing the ion, the charge. Okay, I'm going to write it like that. Na is the chemical symbol, 1 plus shows it's not an atom anymore, it's a positive 1 plus ion. And I can write fluorine ion like that, F for fluorine, but 1 minus shows it's no longer an atom but an ion because it's gained an electron. He's lost 1 electron, he's gained 1 electron. They're both ions. And of course now the positive ion and the negative ion are attracted to one another because opposite charges attract, and they come together to form the compound NaF, sodium fluoride. All the positiveness of this sodium ion is cancelled out by all the negativeness of this fluoride ion. 1 positive cancelled out by 1 negative to make NaF. Now, our question wasn't... Oh, hang on, no, I haven't finished yet. So that's the last time we're going to draw anything other than the outer shells, because it's only the outer shells of of atoms that do the bonding. So an easier way to draw all that would be to draw Na. There's its outer shell, 1 electron. There's fluorine. There's its outer shell, 1, 2, 3, 4, 5, 6, 7 electrons. Sodium atom meets fluorine atom. The electron is given away. There's sodium becoming a 1 plus ion, square brackets around the Na, 1 plus, and there's fluorine becoming a 1 minus negative ion. And there's the electron, there's the cheeky electron that used to belong to sodium, now belongs to fluorine. Fluorine is not an atom anymore, it's a 1 minus ion. Sodium is not an atom anymore, it's a 1 plus ion. Na plus, Na1 plus, F1 minus are attracted to one another because opposites attract, and I make sodium fluoride. Okay, so all well and good. But back to our question. Our question says, describe what happens when 2 atoms of potassium react with 1 atom of sulfur. Okay, so here we go then. Here's 2 atoms of potassium, both with 1 electron in the outer shell. Here's 1 atom of sulfur with 1, 2, 3, 4, 5, 6 electrons in the outer shell because it's in group 6. How do these guys get a full shell? Well, they're going to give the electron to sulfur, and he's going to give his electron to sulfur. And there they are now, look, with a full shell. The shell we don't bother to draw because it's underneath. Okay, and they've lost an electron, so they're no longer atoms, they are 1 plus ions. And I've got 2 of them, K square brackets 1 plus and K square brackets 1 plus. Meanwhile, the sulfur has taken those 2 electrons that used to belong to the potassium atoms and put them in its outer shell. So its outer shell now has got 1, 2, 3, 4, 5, 6, 7, 8 electrons. 1, 2, 3, 4, 5, 6 have always belonged to sulfur, they're the circles, but 2 used to belong to the 2 separate potassium atoms. Sulfur is now no longer an atom, it's gained 2 electrons, so it's got 2 lots more negativity than it has protons in the nucleus. So I put square brackets round it and it is a 2 minus ion. Now, I've got some positive ions and some negative ions. They're attracted to one another by the strong force of electrostatic attraction. Opposite charges attract. Okay, 1 plus potassium bonds with an S2 minus, but that doesn't cancel out all the the minus, does it? That cancels out only one of the minuses, and I've got 2. So I need another potassium ion to fully cancel it out. 2 lots of 1 plus cancels out 1 lot of 2 minus, and the formula is K2 because I've got 2 potassiums, S, K2S. Right, and the simple way of drawing that, well, rather than drawing 2 potassiums, which is a bit of a waste of time and ink, I'm just going to put a big 2 in front of my potassium. Okay, there's its electron in the outer shell, meets 1, I could put a 1 in there if I like, yeah, I don't normally bother, could do if I want, bit of a waste of time. 1 sulfur atom with 6 electrons. The 2 potassiums now become 2 potassium 1 plus ions, and the sulfur becomes 1 sulfur 2 minus ion. And there are the electrons that used to belong to sulfur. They've been given, used to belong to potassium. They've been given by potassium to sulfur. 2 potassium ions and 1 sulfur ion in a compound is the formula K2S. Right, Mr. Ashton-Tyler, are we going to finally answer the question? Are we finally going to answer the question? We are going to answer the question. Right. Describe what happens when 2 atoms of potassium react with one another, 1 atom of sulfur. Give your answer in terms of electron transfer. Well, the first thing we're going to say then is 2 potassium atoms each give, and give is the important word. They don't share, they give their 1 outer shell electron to the sulfur atom. So each potassium gives its 1 outer shell electron to sulfur. 2 potassium atoms each give their 1 outer shell electron to the sulfur atom. The potassiums are now positive ions with the formula K+. Okay, that's they are, or K1+, let's keep it consistent. There they are, no outer shell electrons, K1+. The sulfur atom, meanwhile, takes, okay, doesn't share, it takes. The sulfur atom takes the 2 electrons, okay, there it is, it's taken the 2 electrons, there they are in the outer shell. The sulfur is now an ion with the formula S2-. There it is, S2-, because it's got 2 extra electrons. As it turns out, for this question, that's as far as you needed to take it, because all you were doing is explaining in terms of electron transfer and the formula of the ions formed. So 1 mark was for saying give, 1 mark was for saying an electron each from potassium, 1 mark was saying that the sulfur takes 2 electrons, and then there was 1 mark for K1 plus or S2 minus, and 1 mark for S2 minus. If you wanted to be really complete and amazing, you'd say that the positive potassium ions are attracted to the negative sulfur ions because opposite charges attract, and the force of electrostatic attraction between the K plus and the S2 minus, K1 plus and S2 minus, is the force holding the ions together in the ionic bond. That would absolutely guarantee you all the marks.